In this video, we're going to find the volume of prisms. So the figure to the right is the same shape as the previous example from the text, but rotated a quarter of a turn. Find its volume by using the top of the figure as the base. So here's the previous picture from the text, and this is our new figure. And notice it's the same as this. You can just imagine that it was a box and we rotated a quarter of a turn. Okay, so we are told to use the top of the figure as the base. So notice this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can look at the corresponding measurements. It's 3 yards by 4 yards. So 3 yards times 4 yards means the base is 12 square yards. Now the height of the prism is the distance relative to the two bases. So this is the top base, and even though we can't see it, there's a bottom base underneath, and the distance will be this length right here, which is 5 yards. Now our volume is the area of the base times the height, so that's 12 yards squared times 5 yards. 12 times 5 is 60, and now we have yards squared times yards gives us yards cubed, the little cube that we're measuring with here. And now we're asked, how does the volume of this figure compare to the volume of the previous example? Why do you think this relationship holds? So we found the volume of this other cube was also 60 yards cubed, so the volumes are the same. And the reason is it's the same general shape, we've just moved it in a different direction, and when you have a rectangular prism, it doesn't matter what two sides you use as the bases, since all of the opposite sides are parallel and identical. So we can also say mathematically and more simply, when we found the area of this base, or the volume, the area of the base was 12 yards squared times 5 yards, which gave us 60 yards cubed. When we used this version, we did 5 yards times 4 yards, which was 20 yards squared, times the 3 yards, which gave us 60 yards cubed. So notice they have the same three factors, 3, 4, and 5 in each case, so we're going to get an identical answer. Let's look at the next one. Okay. Write all the indicated measurements and attributes of the given prisms, then find the volume of the solids. Include units in your answers. So remember, an important part of finding the volume of the prism is we need to find the bases, and there's two bases and they're parallel and the same shape. So notice you could think here's a side and here's a side, but they are not parallel. So we're going to shade the sides that are parallel and the same shape, and that's going to be this triangle and this triangle. Okay, and you can see these are the sides connecting those two bases. Okay, so the shape of the base is a triangle. So we'll start by finding the area of that base, which is 1/2. Now we use base with a capital B here. When we find the area of a triangle, it's 1/2 the base times the height. We use a little b so we can compare them or tell them apart. So this would be 4 times 4. So 1/2, 4 times 4, which is 2 times 4, which is 8, and the units are centimeters squared. Okay, now the height of the prism, typically we think of height as going from the bottom to the top, but remember the height is the distance between the two bases. So this is our base, this is our base. The distance is 8 centimeters. And our volume is the area of the base times the height. So 8 centimeters squared times 8 centimeters. 8 times, oh, that one wasn't squared, sorry. 8 times 8 is 64. And then we have centimeters cubed would be our measurements. Let's look at the next one. Now here, First we want to start by determining the shape of the base of the prism. Okay, and notice the sides that are parallel are this trapezoidal side and this trapezoidal side. So if you look at the other side, this side is parallel to this side, however they are not identical. So remember, when we're finding the volume of the prism, we're focusing on finding these parallel identical sides, and then once we find the area, it's like we're taking slices out of it to find the volume by multiplying by the height. So there's a base, and there's the other base. So the shape of the base, it's four-sided. It has one pair of parallel sides, not two, so it is a trapezoid. Now the area of a base of a trapezoid, we said it's 1/2. We take, so this is our trapezoid, so we're just going to focus here. We take the two parallel sides, so this side has length 9. This side, we have to look over here to see its length. This is 3 feet, probably because it couldn't fit in the diagram. They wrote it back there. So this is 3 feet and this is 9 feet. So remember, we add those together, and then we multiply by the height. And this dotted line right here is showing us from the bottom of the figure to the top, which is the same as the distance from the bottom of the trapezoid to the top, is 6 feet. Okay. So now we can multiply this. This is, well, first we'll do the parentheses, 1/2 times 12 times 6. Okay. 1/2 times 12 is 6. 6 times 6 is 36. And this is an area, so it is feet squared. Okay. Now the height of the prism, or the distance between the two bases, well, here's one base, there's the other. The distance is 12 feet. And now we're going to find the product to find the volume. So we have 36 square feet. 36 square feet times 12 feet. Okay, and we'll use the calculator to compute this. 36 times 12. So we multiply the numbers. We have 432. And our units are in feet cubed.